Okay, so what I'm going to do is work up the data from Bill's experiment. And then what I'll do is I will send you the PDF of it, and then I'll also send you this if you want to see how I did it. It's up to you. So the first thing I'm going to do is, this is the exact data that Bill sent, or Bill took in the video. So the first thing I'm going to do in this is to calculate the change in temperature for each of those reactions. And so here we go, 70.1 minus 23.3, and I get 46.8, and then I'm going to do 29.9 minus 23.1, 6.8. And so really what these calculations are going to be a lot of Q equals MC delta T. The important thing though is when you do the calculations using Q equals MC delta T, the M is the mass of the magnesium plus the HCl, or M is the magnesium oxide plus the HCl. In both cases, the heat capacity should be 4.184 joules per gram degree C. We're going to assume that it's going to be the same as water. So in the first part, he used 1.332, and I'm going to add the 117.279. I get 118. The total mass is going to be 118.611. And then for the second one is 1.043 plus 110.180. And I got 111.223. And so the change in temperature is going to be 46.8, and then this is going to be 6.8. So we're going to come down here, and I'm going to do this calculation. So for the Mg part, okay, Q equals MC delta T, which is going to equal 118.611 grams times 4.184 joules per gram degree C times 46.8 degrees C. And I got an answer of 118.611 times 4.184 times 46.8. And I got 22.225, 23,225 joules. And I'm going to convert that just to make my life easier, 23.225 kilojoules. Okay, and so that's, so that's 23,225. Okay, and then I'm going to leave a little bit of space for the MgO. Okay, it's going to be the same calculation. Q is equal to MC delta T, which is equal to 111.223 grams times 4.184 joules per gram degree C times 6.8 degrees C. I'm going to get a lot lower number, but that's okay. 111.223 times 4.184 times 6.8. And I got an answer of 3,164 joules. 3,164. Now, in both cases, because the temperature went up, our Q should be negative. Our Q should be negative. So this technically should be negative 23.225, because the thermometer is in the surroundings. And so this should be negative 3,164 joules. So what we need to do, the next step is to calculate delta H. And so what has to be done is we need to get the moles of the Mg and the moles of the MgO. So if we come back up here, we use 1.332 grams of Mg. So 1.332 grams Mg times 1 mole Mg divided by, get my periodic table, 24.305 grams. So 1.332 divided by 24.305, and I got an answer of 0.0548 moles. So the delta H for the MgO is going to equal a negative 23.225 kilojoules divided by 0.0548 moles. And I got an answer of 23.225 divided by 0.0548 negative 423.8 kilojoules per mole. So that would be over here, negative 423.8 kilojoules per mole. I don't need the unit because it's right there. I've got to put the 8 back. Okay, so and then for the MgO, we go back up here and it's 1.043 grams MgO times 1 mole MgO. And if we take a look, I'm going to use the internet for this. MgO molar mass is 40.3044 grams. So if we take 1.043 and divide that by 40.3044 grams, I got an answer of 0.0258 moles. So then our delta H is going to equal negative 3164 joules divided by 0.02588 moles, and that's going to equal 3164 divided by 0.02588. I got 122,256 joules per mole. I'm going to convert that over, and I got divided by 1,000, and I get an answer of negative 122.3 kilojoules per mole. So then this is going to be a negative 122.3 kilojoules. Sorry, I don't need the unit. So that's the data that we have. And so now what we need to do is to answer the questions. And so it really doesn't matter what the mass of the Mg is, because in the end, when you divide by the moles, you should always get roughly the same number, which is hopefully going to be minus 423 for the Mg and minus 122 for the MgO. So I'm going to use this data, and if we take a look on page, let's see, so that was page 123, this is going to be page 125. Okay, and so if we take a look, the enthalpy change for this reaction, for reaction 1, was minus 423, I'm going to go back up, sorry for the motion, 423.8 kilojoules per mole. The one thing we need to just remember is in the next, is this reaction here, I'll highlight it, okay? This is the reverse reaction. So this was the reverse reaction So what we need to do, we need to manipulate this reaction by flipping the sign, okay? Or is there a typo? Hold on one second. Let me just double check the first. I'm going to just look at the lab manual. Something seems slightly wrong. It could be me, but I think I'm going back to page, hang on one second. I'm going to page, here we go. I'm going to go to page, page 118, and it looks like actually that first reaction is correct, and then the second reaction is going to be, the second reaction is correct also. So, okay, so what I'm going to do now is then we're going to flip the reverse reaction. So this should be a positive 122.3 kilojoules. And so if we add this up, okay, what we're going to do is we're going to take those three reactions here, and I'm going to add them up, and it should hopefully add up to this reaction here. So here we go. It's going to be Mg. I'm going to just drop the solids plus 2H plus. Yeah, so we got to reverse that. Okay, my mistake. Okay, so what we're going to do is erase all this. And what I need to do is I'll come down here and manipulate it. Sorry for the confusion. Mg plus 2H plus. Okay, goes to Mg2 plus H2. That delta H is going to be a negative 423.8 kilojoules per mole. I need to reverse this, the second reaction there, so it's going to be Mg2 plus H2O goes to there. That's MgO plus 2H plus. And because I flipped it, it's going to now be positive 122.3 kilojoules per mole. And so in reality, this reaction there at the top should actually be a negative. So I'm going to change that. But when we reverse the reaction, it becomes positive. And then if we do 1/2 O2 plus H2 goes to H2O, this delta H is negative 285.8 kilojoules per mole. Now, ideally, when we add this up, it should add up to this right here. I'm going to change my color. Purple is a nice color. And it should have a delta H near there. So let's take a look. So the first thing I'm going to do, I like to do it the long way, Mg, and just write all the reactants out. H2O plus 1/2 O2 plus H2. And then I'm going to write all of the products out, H2. And then what I'm going to do at the end is I'm just going to cancel everything that's the same on both sides. And I think we're going to have a lot of cancellations. And so now what I can do is I'm going to change it to red. And so you'll see that this Mg cancels with that Mg2 plus. This H2O cancels with that. This H2 cancels with that. And this H2 plus cancels with that. And so then what we're left with is Mg plus 1/2 O2 goes to MgO, which is exactly what we want. Now, to calculate the delta H for this, delta H is just going to be adding them all up, just making sure that negative is flipped. So, here we go, negative 423 negative 0.8. 423.8 negative plus 122.3 plus 285.8 negative equals, and I got a delta H of minus 587.3 kilojoules per mole, which isn't bad. And so let's do a percent error, because the actual is up here. The actual is negative 601. So percent error is going to be, I believe it's experimental, 587.3 minus negative 601.7 divided by negative 601.7 times 100. And I got an answer of, so here we go, 587.3 negative minus a negative 601.7, and I'm going to divide that by 601.7 negative, and I got an answer of O times 100, and I got an answer of negative 2.39%. And so that's the manipulation for that, and I'll take a look at the questions, but I just wanted to get this part done to show how I would have done those calculations. I'm going to send you this video, and I'm also going to send you the PDF of this right here, okay? I hope this helps. Please don't hesitate to ask questions, because I do have a fair amount of time on my hands, and I want to be as helpful as possible. Thank you. Good luck.